So we'll do the best we can to keep you entertained, hopefully educate you to some extent over the next, I don't know, 40, 45 minutes or so. But again, thank you for attending the AWS Summit in general, and specifically this particular session, which is building and growing SaaS on AWS for partners. I'm Brian Matsubara, so I'm the head of Global Technology Alliances. I have the good fortune of having a team that looks after all of our ISV partners on a global basis. So these are any technology companies who are building commercial software for business use that customers then will deploy and run on AWS. I'll talk a little bit more about the ecosystem here in a second to give you some context, and then more specifically about the SaaS Partner Program that we're doing a soft launch for as of today. So to let you know what we're doing to build that space. My co-presenter today, my partner in crime, is Matt Tavis, Principal Solution Architect. So he's the smart one of the two of us, so they let me go first to cover all the business stuff, and then he will dazzle you with diagrams and fancy acronyms. I'll try to keep it light on acronyms. But first, let me just explain the ISV landscape as far as how we see it. If any of you have seen these presentations before, this will be somewhat similar. But you know, a lot of times people think about the cloud and it's so different and it's just, you know, it's this mystical thing and people do magic and conjure up servers. But fundamentally, from an architectural standpoint, if you look like a block diagram with traditional on-premises deployment, obviously you start with hardware, or in this case, AWS, right? We happen to put a hypervisor on top of it for virtualization and multi-tenancy. But fundamentally, the software stack is not much different than what people require when they're deploying things on premises. Right, so operating systems, networking, software, databases, DevOps, storage, security, et cetera. Right, so part of our ecosystem is targeted at working with these types of ISVs to make sure that their software is made available for customers to deploy on AWS. Then, of course, there's the application level software, right? So the horizontal applications for actually solving line of business needs, right? Things like big data and analytics, BPM, CRM, et cetera, et cetera, et cetera. We work with all the major vendors in these particular horizontals to make sure that their software is made available in our environment. And then finally, there's the verticals. So we're actually we've evolved the ecosystem to a point now where we're actually building out specific disciplines around vertical industries, right? So there's very unique ISV ecosystems around life sciences, around healthcare, around media and entertainment and financial services. So this is how we look at the world. Now, there's other categories that we focus on. I kind of simplified this for the sake of this presentation, so I wouldn't ramble too far on. Now, what people do, what a lot of people do is like, look, they'll take a subsegment of these. Usually it's multiple software components that they then go and stitch together themselves and run it on AWS, just like you would run it on any other type of hardware environment, right? Or likewise, you would go and find a media-based solution that, again, runs on top of operating systems and databases and things like that that run in AWS, right? So when we're looking at building out the ecosystem, we're looking for all the ISVs to create the infrastructure and application components so people can assemble their own software on our platform. Now, of course, there's multiple different ways in which the software can be licensed and therefore delivered to customers in the market, right? So first is, this is nothing new either, it's free trials. So AWS, we've invested in a number of platforms that make it easy for our ISVs to make their software available for demonstration purposes, right? Where you can actually stand up complex multi-node architectures up on AWS in a very fully automated manner. So we call that the AWS Test Drive program that allows our ISV partners to leverage this platform and provide on-demand demo environments. For free trial, it is what it is. It's customers, you know, we're not charging the customers for it, but they get to kick the tires, so to speak. From commercial licensing models, there's really three. One is utility-based, right? So this is one of the unique characteristics of the cloud when compared to on-premises, where the price of the license is somehow embedded into the variable use component of the infrastructure. In this case, let's just say hourly. And we have the AWS Marketplace, right, which is not only is it a channel for ISVs to go to market, but also serves as a billing and metering platform. So as an ISV or somebody who's developing software, you don't have to worry about how are you going to measure the usage of your software on AWS. The marketplace will meter that for you and then bill on your behalf, and then basically allow you to actually sell through this self-service channel. So utility is, again, it's fairly new in the cloud, but it allows customers to spike up and down, not just the hardware components, but the software as well. License mobility. This one, again, this one's pretty easy and very, very basic, right? Where a license for software is a license for software. And most software vendors don't really care where that software is actually deployed, whether it's deployed on a physical machine and whether that machine is an OEM machine, from an IBM machine, a HP machine, a Dell machine, et cetera. Doesn't really matter. Similarly, they could run that software and bring that license to the cloud in something that we call bring your own license, or BYOL. Right? So those are the two main type of commercial software license models where the end users actually managing the software themselves as if it were in their own environment. The last one here, the last and definitely not least, is software as a service. Right? Now, this one, of course, is fully managed. The ISV themselves actually create a multi-tenanted architecture on top of AWS, and therefore they license the software in any way that their customers want to buy it or that they are able to bring it to market. Typically some sort of a monthly or annual subscription by user, by data used, et cetera, et cetera. The ISV is really in control of charging the customers however they want. AWS actually provides global infrastructure for helping them get to market. So it's this last one, SaaS, so we're going to spend the rest of this talk discussing about and diving in a lot more detail. So let's talk about the power of SaaS for a minute. Right? So the world is moving to SaaS, and I would say actually the world is moving to service-based delivery in general, right? Whether it's on-demand TV programming or streaming music or whatever it may be, or buying things from Amazon.com and having it delivered next day and all those types of things, right? We are as a culture, as a society, we are becoming programmed and accustomed to service-based delivery, right? Get what you want when you want it. But this IDC, this is actually from December 2013, but IDC believes that in 2017, about 26.2% of all new business software will be delivered as a service, as a software as a service, and that SaaS delivery would constitute 18% of all software spending and nearly 20% of all application spending. I'd argue that that this was done in December 2013. I'd argue that these are actually fairly conservative estimates. From what we've seen in our ecosystem, a large majority of our ISV partners who have installable software are also delivering their software to market via the SaaS model. But why is SaaS good for ISVs? So why are these ISVs now implementing pure SaaS or SaaS only, or migrating existing software to a SaaS delivery model? There's several real fundamental value propositions of SaaS in general. One is it allows the ISV to sell more, right? Sell more in two dimensions. Sell more from a geographic standpoint, where an ISV in India can now actually sell a hosted ERP solution to a customer in Latin America, right? Companies like Ramco, for example, right? Where they don't have to go set up a footprint now in Latin America to be able to cater to that market. By working in the cloud and delivering your product over the internet, you actually can reach customers around the globe where you previously weren't able to. And also being able to sell to different market segments, right? So if you have traditionally had complex enterprise software that required a very robust IT staff, and small to medium businesses or even small to medium enterprises might not have had the skill sets required, well, SaaS takes all the complexity out of that. So it allows these ISVs to sell to a bigger section of the market. The next one is sell faster, right? If you look at the average sales cycle for enterprise software, it's probably around 9 months or so. If you look at the amount of time in that 9 months that actually has to do with demonstrating the value of the software itself, it's probably about a couple of weeks, right? So if you're able to instantly spin up a demo environment and provide your customers with instant time to value for your application, and you can shorten the sales cycle from 9 months to, let's call it a month, that's a good thing. Any software company I've ever talked to, or any company I've ever talked to, said, hey, if there's a way for you to sell more and sell faster, that's a good thing. And it's somewhat self-evident, but yes, absolutely. The next is improve the customer experience, right? The distributed computing, when we moved from mainframes to distributed computing, one thing happened, which was increased diversity, which was great. Customers could choose from different providers and different suppliers, which helped drive down the cost of computing in the market. Right? But what it did is, on the flip side of that, it actually increased complexity. right? Because now you have all these different components made by multiple vendors, you have to have people to stitch it all together. And the time to value was lengthened because it required everything to be delivered and stitched together. Well, with the software as a service delivery model, it's instant, right? So you improve the customer experience. Customers don't have to do upgrades. Customers don't have to do security patches. Customers don't have to manage the systems themselves. It's simply consuming it as they use it. And then finally, for an ISV, reducing the support and engineering expense. Prior to the internet and prior to the cloud and prior to software as a service, one of the biggest cost centers for an ISV would be where the money that they had to spend on sustaining engineering and support of legacy applications, right? Because once a customer would typically do a deployment, they're not going to touch it if they don't have to, right? So ISVs have to support multiple versions of their products on a near infinite number of configurations of hardware platforms, add the number of operating systems on top of that, and then add a virtualization layer on top of that. It becomes this very complex, very hairy matrix of support dependencies that you have to maintain. Well, if you deploy via SaaS, again, you build your software for one platform, the one that you control, and therefore you can take the money that would other ISVs spend on sustaining engineering and move that into product innovation. Right now, so why SaaS on AWS, right? So, I think if we can all agree that SaaS is a great way to deliver your software product, why is AWS a good place to do that? Or the cloud in general, but of course we're with AWS, so we're specific to AWS, right? So what are the characteristics of SaaS, right? One is price based on value, right? You're buying a user seat per month, or you're buying some sort of throughput per month, or something like that. But you really choose a package that caters to your particular need. You don't have all the ancillary costs associated with getting that stood up. So it's price based on value. It's self-service, right? You go to a website, you sign up for it, you tell somebody how much you want, it's provisioned, you get access, and you're off to the races. It's multi-tenanted and shared infrastructure, right? So SaaS in general tends to be multi-tenancy, provides better economies of scale for the ISV, but also provides, it makes it easier for the ISV themselves to spin up a new tenant when a new customer comes on board. And elastic usage, right? So elastic usage from two standpoints. One is if you need to add a new user, no problem, add a new user, right? Pay for another subscription, you get a new user. You need to add 100 more users, no problem, add 100 more users, right? But also elastic from a capacity standpoint. If you're using a SaaS service and you happen to have to use a tremendous amount of, say, analytics to actually run some sort of business report. Well, if it's a SaaS-based delivery running in the cloud, you're able to benefit from elastic usage. And then finally, global market. Talked about this, being able to sell to customers in different geographies. Right, so AWS characteristics. Well, pay for use. And that's something that we somewhat pioneered out there in the market as far as utility-based pricing, pay for what you use and only when you use it. Right? ISVs who are delivering SaaS are a perfect complement to what AWS does, where we provide infrastructure on a pay-as-you-go, as-you-need basis, on a value basis as well. SaaS is a perfect complement for the business application tier. Next is resources on demand. So it's there when you need, for an ISV who's building SaaS on us. AWS has the server capacity, the storage capacity, the networking capacity for our ISV partners when they need it, and more importantly, when their customers need it. Next is highly scalable and durable services. So we, of course, have SLAs associated with our services, but we work with our ISV partners, and Matt Tavis will talk more about this, on how to actually build highly resilient, highly available architectures on AWS. Oftentimes people ask us, well, what's your DR strategy in AWS? And my response to that is, well, in the cloud, high availability is the new disaster recovery, right? It's not disaster recovery, it's disaster avoidance, and you can actually architect your way into that realm. Next, auto-scaling based off of scriptable usage. So if you're an ISV, and again, your customer has to scale quickly, you can scale with them. And then, of course, global reach, where AWS now has 11 regions around the world, as Andy Jassy mentioned today in the keynote, and we're investing heavily in bringing more on over the course of time. All right, so there are many paths to SaaS, right? So not all ISVs are created equal, and some ISVs that hopefully we'll be working with closely in the coming months or years probably don't even exist today, but maybe some of you in this room will be founders of those, right? But one is evolve, right? So A partner of ours like Infor, right? Infor has been in the market for a long time. They have dozens, if not hundreds, of different types of line of business products that that were already engineered for on-premises type deployments, right? Well, Infor is fundamentally evolving the way they go to market, redesigning the application interface, redesigning the way the applications are looking for computing resources and how they actually work on AWS, so that they are evolving from an on-premises world to be in the cloud with their Cloud Suite products. And AWS, we've been working with them for over 5 years now. The other one is Extend, right? So companies like partners like Pegasystems, who does commercial business process management, right? Where customers might have a on-premises implementation of Pegasystems, right? But they actually now need to have different functionality. So for example, if they need to test a workload, a workflow before they implement it in their business process, they can actually test that in a automated environment stood up in the cloud. If they then also want to just deploy that to AWS, in the AWS cloud, they can do that as well. So extending from an on-premises environment up into the cloud. Next is innovate, right? An innovative approach where you take a partner of ours like Acquia, right? Who are the leaders in Drupal and Drupal content management for rich dynamic websites, right? Well, what they've done is they stood up fully managed Drupal environments that power some of the most popular and some of the most beautiful websites in the world, all running on AWS. What they did was, again, they took a bit of open source technology and they built a service around that. So they put some innovation into how to do a managed service of Drupal on AWS. And the last one would be innate. Those who are born in the cloud, right? Those who don't have any of the legacy dependencies, right? They've built their business with the cloud in mind, the cost model of the cloud in mind, the buying behavior of customers in mind, and they're started from scratch. One of our favorite case studies here is Sumo Logic. Sumo Logic, we became aware of them probably about 5 years ago. They're quite a small, scrappy startup, and now they are a force to be reckoned with in the big data and log analytics space. But 100% built from scratch on AWS, innate, cloud-native ISV. So I'm going to talk a little bit more now about what we, AWS, are doing to help make AWS the best place in the world for ISVs and developers to run SaaS businesses. So at reInvent in November of last November, we announced the SaaS Partner Program. We are now actually doing a soft launch as of today, allowing people to start to sign up for this and take advantage of some of the benefits. We were very prescriptive in how we wanted to build this program, right? Because we wanted to make sure this program was available at various stages that our partners were made available to partners no matter what phase or tier they were in the APN, which is AWS Partner Network, right? So it starts at the learn phase, right at the bottom. The learn phase, this is where we're building a community of SaaS partners, right? It's a community where we can actually broadcast out information to this closed community of our SaaS partners and developers around best practices, right? About webcasts on how to actually do technical implementations. Where we'll host office hours, right? So twice a month, we'll have office hours that will allow you to sign up, log in, and then you'll have experts on AWS who will be there to be able to answer questions. And I believe we're going to start launching the first version, the first editions of office hours come May 1st, right? As well as technical and business specialized content, right? So we'll be providing all this so that the community can actually learn, get the resources they need to understand how to build a SaaS on AWS in the best way. But also it's a community, we're going to build this community type of environment where you can collaborate with each other, share ideas, share best practices with each other. Probably more importantly than that, collaborate together on what type of platform enhancements that you want to see from AWS. Because a lot of the requirements that SaaS providers have are very similar, right? If you think about it at the platform layer, a lot of that's just plumbing. So if our SaaS community is able to collaborate with each other to help prioritize the platform enhancements they want to see from AWS, that collective voice is much louder than individual voices making the same ask. Right, so that's the whole idea around the learn phase, right? It's the community and the place you go to understand how to build SaaS on us. And then it's going to be build, right? So once you have an idea and you now are ready to go build something, right? Well, we're going to have different program benefits associated with this as well. Right? So training and certification to help get you fully skilled in AWS. The ability to apply for development funding, right? Well, we will actually be able to help provide AWS credits to offset the cost of standing up a development environment in AWS because you're just starting your build process, right? And again, some other types of SaaS-specific reference architectures to help you along the build phase. And then finally, the grow phase. So you launch your offering, right? From AWS's standpoint, we have a vested interest in helping you attract as many customers as possible. The more customers you attract, the more money you generate as a company. Therefore, the more customers you have on your platform, the more customers or resource requirements you have for our platform. So it scales the use of AWS indirectly. Right? So we have access to budgets and we have access to funding programs that will help our SaaS partners launch products, do promotions around their products, do lead generation campaigns, in some cases do strategic sales alignment with the AWS field. Right? But these are all the different areas as our partners move up through the various stages. This is a quick snapshot of the benefits of the program that are going to be coming out at launch. And official launch, so we're doing a soft launch now, April 9th. The official launch will be at Sydney on April 22nd. But these are the benefits that you'll see when the program's officially launched on the 22nd. But you can see how there's different benefits based off of what stage you are in the program. But again, we want to make sure that partners, regardless of whether or not you're a registered APN partner, standard or advanced, that there's benefits that you're actually entitled to at the various stages. So for example, the webcast, the specialized technical training content, business hours, training and certification, and things like that, those will all be made available to customers, to partners in all tiers. Right? Part of the fun that we're going to have with this program too, though, is we're going to allow you to share with us the ideas that you have for the SaaS product you want to build. Because in some ways, it's actually going to be a fun exercise where you submit a request to say, hey, I have an idea. I want to actually go build a SaaS product. We'll say, okay, great. Well, give us what is it? What are you going to build? What's the target market? Right? What is your go-to-market strategy? Who is the ideal buyer? All these types of things. How is it differentiated from other things in the market? And this will allow us to help you think through the business model, as well as give us a sense as far as what niche you'll fill out there in the ecosystem, and then we'll invest based off of the merits of the business plans that come through. Right? And the same thing, we'll have a similar vetting process when it comes to investing in MDF and other types of marketing dollars. So once you actually apply, and we'll cover this in the wrap-up, once you apply for the SaaS Partner Program and you get accepted, you get access to an APM. Well, being part of the AWS Partner Network, you get access to an APM Partner Portal in general. There's going to be a section of the APM Partner Portal specifically for those who have applied for the SaaS Partner Program and who were accepted. Right now, even though we did a kind of a stealth launch after reInvent, we have 50 SaaS partners that are currently enrolled in the program today. After the official launch on the 22nd, we expect this to grow into the hundreds very quickly. Right? But you'll have your own special area of the APM Partner Portal where we'll be able to provide and communicate to you the different types of benefits per tier. So that's just an overview of the program. I'll be here after the smart guy comes up in here and talks to you about how to build cool stuff to answer any questions you may have about that. So with that, smart guy. Matt Tavis.
Wow.
All yours.
You teed me up for failure fantastically. Cool. Well, hopefully I can live up to his introduction. That'd be good. My name's Matt Tavis. I'm actually a solutions architect with AWS. I've been lucky enough to have been doing that role for 5-6 years now. I've been at Amazon a little over 9. So it's been a fantastic journey kind of as we watch this platform evolve and grow. And I think now we're kind of getting to the point where we really have the services and tools to make building kind of this next generation of software on top of the platform certainly easier than it was a few years ago. So I'll jump through some of the technical stuff. So hopefully it's still interesting and you still want to listen to the technical stuff. I got some charts to look at, some diagrams. But first I want to make a point that kind of reiterates Brian's comments earlier around how the business is evolving from software delivery perspective. When you look at the history of software and kind of where people were building it, they were building this IP and they were shipping CDs, right? That on-prem model, you sell them a CD, you mail it to them, or they come download it from somewhere. They install it. They have this problem of installing it, configuring it, putting it on the servers, running it. Then there was, hey, let's do some application hosting. And many people who call what they do today SaaS, it still fits kind of this application hosting model. I'm running a set of infrastructure for you, and that's really kind of my offering, if you will. But still, it's really about individual environments, individual complete architectures for that platform. And then there's, hey, let's start using things like AWS in the cloud, making a lot of this stuff significantly easier. But that's really not far enough in terms of where things are going from a software delivery perspective. It's not about installing it. It's not about configuring it. It's really moving from shipping bits and writing code to actually running services. And that's really the shift that's occurring from a SaaS perspective. And that's how what you do on a day-to-day, if you're building your applications, is changing as well. The emphasis is not just on making the code optimized, it's also making the code run and operate in a highly available, highly reliable environment that runs 24/7 as a service. So with that, here's the diagram. This is pretty obvious, right? You're just going to look at that. I don't need to explain this, right? Fairly straightforward. I got excited. I started using cross-hatching and various background fills. It was pretty exciting. But the idea here is really the top right is your application. How you build your applications, stays the same in a lot of ways when you do it a SaaS model. You're thinking about highly available, highly scalable, auto-scaling, multiple AZs, how to make that application sing. But it's really all the stuff around it, this platform that is actually changing when you think about a SaaS model. The app itself is still designed, service-oriented architecture, highly distributed, but now you have to think about how am I going to handle ordering? Like, how does somebody order this service? How do they pay for it? What's my provisioning solution? Is it fully automated? How do I spin up an environment on demand? How do I think about application lifecycle management? If you're running this thing 24/7, you have to have a model of blue-green deployment, dynamically switching from V1 to V2 in the environment. How are you going to handle that? How are you going to deploy that code real time? And then on the business services end, how are you going to handle billing? Well, billing, previously you probably had some sort of billing system, but a lot of billing systems were built around I might charge people once a month. I might send them an invoice. Now we're sending very, very detailed, granular, per gigabyte charging. You look at what your AWS bill looks like. Imagine trying to build that kind of a platform for your SaaS offering as well. Maybe not quite as granular, but that's a piece that's part of this platform as you move to a much more usage-based model. And analytics, which I can't stress enough, and my last best practice slide is really all about it. What is your approach around how you're analyzing the environment, analyzing usage, analyzing what's happening? One of the big changes that's occurring here when you go to SaaS is that you now have a really detailed view of what your customers are doing with your software. Before, you shipped a CD, and now you hoped they were using the features you put in there. Now you actually see what they're doing because you're running it for them. You get a detailed view that you can really, truly analyze that data. And then, of course, core platform services, metering, monitoring, authentication and authorization. You have to think about some of these things as not just part of an app. It's not just logging, on the server, but now it's how do I have a real-time view of not just this version of the app, but every version of the app? How do I know what real-time is happening in terms of usage and consumption, and have that business view? And what are the core services I need to have sit behind that? And in many cases, these aren't, you don't necessarily have to build these, but you have to have a solution around them. You could be using another SaaS provider, for example, that's providing you a monitoring solution on top. So it could be a composition of services. Your SaaS relies on another SaaS, for example. So some best practices that I want to make sure, if you're thinking about building a SaaS today, that I want to make sure these are things we've learned from our customers and the experience we've seen out in the field. The first is to think about separating that platform from the product, right? Or the program itself, the application. They are distinct things. You want reusability. You want to evolve your application over time. So you're going to have a V1, and then you're going to get feedback. It's not perfect. Never is. And now it's a service, so it's not like a shipped product. It's not like a V1, V2 thing. It's a constantly evolving platform, which means you're going to want to decouple a lot of those core services from the application that allow you to evolve that application quickly over time. So really separating out the metering, monitoring, billing, analytics from the application itself. So you can do a V1, V2, V3 real time, very quickly move and evolve. Obviously, you can use this suite of services to support a fleet of SaaS applications. Don't limit yourself and think that you're going to build just one SaaS app. And even if you do just build one SaaS app, you're going to have lots of versions over time. So think of each version as another application. And you have to think about how do I support that and how do I evolve that over time. So definitely an important component there in terms of decoupling. And of course, the nice thing about doing this kind of distributed model, which really fits very closely with service-oriented architecture in general, is the idea that you can tune and optimize individual components, right? So the load that you're going to take in your metering platform is different than the load you're going to take in your billing engine, is different than the load you're going to need for your analytics pieces, is different than the load for your authentication and authorization. Each of those is going to need different infrastructure types, different types of throughput for network and CPU and memory. Making smaller components that you can then tune effectively is an important step in your architecture. And I think that it's doubly so when you think about SaaS, because the magnitude and scale is different. When you think about writing an app for one set of customers, that's fine. You may have 1,000 customers, and they might have 1,000 users. Well, now it's a multiplier, right? So 1,000 users is one problem. 1,000 customers with 1,000 users is a much bigger problem. So the scale, it can grow much faster than you imagine. It gets exponential very quickly. So thinking about how to do this up front is key. Now, oftentimes we get this question, which is how do I build my app? Like, what's the approach? Especially if you have something existing. Many customers I've worked with have an existing product. They're like, that's great. I've been shipping bits for years. I have CDs. I don't want to do that anymore. How do I get to this thing? There's really three major approaches we're starting to see develop on top of AWS. And the first is probably the most obvious, straightforward approach. It's really about this isolated customer stack. So each customer gets their own entire stack of infrastructure. It's kind of like application hosting as a service, is the model. And it's a great way to get started. And I'll talk a little bit more about that approach in just a minute. But it's a great starting point for existing software. You don't have to do a lot of changes, but you can get quickly onto the platform. The next is kind of the end state. What about a pure SaaS solution where every resource is shared? You have a pool of servers. That servers can handle a request from any customer and any user of any customer, right? So it then has a much deeper impact in terms of how that code understands dealing with individual customer requests, how it routes traffic inside the environment, but it's a shared pool of resources. Probably the most cost-efficient and cost-effective model, but it adds a significant engineering challenge of thinking about how to handle requests from any customer for any need in a common pool. We'll talk about that one a little bit more as well. And then the middle ground is the third one, which is containerization. You've seen a lot. You saw some announcements this morning in the keynote about how we've evolved and improved our EC2 Container Service. The idea of Docker as a model for doing containers or sub-slicing your infrastructure has gained a lot of ground and certainly a lot of support in the software industry of late. It's a model that allows you to maybe optimize, if you will, the resource consumption so you don't get the sprawl of lots of infrastructure in the isolated stacks, but you don't have to make as many changes maybe as building a pure SaaS model. We'll talk about those in just a second. So the isolated customer stacks, fairly straightforward. I don't think I'm going to surprise anyone here. But the idea here, you have your load balancer, your auto-scaling groups, the entire application stack exists for every customer. And then you leverage our tagging infrastructure as a way to flow the billing information through all the way into your bill. So you can tag all the resources inside that stack with a consistent tagging approach or taxonomy. And cost center equals customer one. And then in your detailed billing report, you can then look and say, oh, well, here's all the resources associated with customer one. And you can choose to swallow that cost and summarize it in your charges to your customer, or you could pass it through, depending on what makes sense for your business model. And this tagging approach is getting better and better in terms of the number of resources and AWS services that support it. So you can really flow this through from a detailed billing perspective. New customer comes along. Provisioning is really about provisioning a whole new stack, right? CloudFormation template associated with the entire stack that installs the software. Adds maybe a user or two to your authentication database or a customer, and then you have a completely new customer stack where it's tagged again appropriately to that new customer. Fairly straightforward model. If you had an existing product and said, how do I make it a SaaS, you'd probably start here. And this may also be a solution. So we've had some customers who are not taking only one of these approaches, but multiple. This might also be the solution if you say, well, I have a special customer that's really big, and they want dedicated infrastructure. Okay. Well, then they could have this particular approach, whereas you might have another class of customer that is happier with a shared pool of resources for maybe a lower price point, right? So you have that flexibility in the platform. So this is your standard isolated stack approach. The shared model says, hey, customer one and customer two come into the same endpoints. Maybe there's some nice domain, special domain names for them to make them feel better. It's their endpoint. But really, it's a shared infrastructure. They're flowing through a common set of resources. The web servers, the app servers understand request X that's coming through my platform is for customer Y, is for user Z of customer Y. And it knows exactly how to handle that. That same server can handle a request from any customer any user of any customer. The benefit of this approach is that obviously more tightly aligns from a resources perspective to exactly your consumption. You're not going to have a partially used server that's sitting in an isolated customer stack. You're going to have a much greater density of, or much higher utilization of the services. And it allows you to also build one code base that you can then maintain. You don't have to worry about as much differentiation between individual customer approaches. The trick with this one, however, is now when you think about how do I meter this, I want to charge back to that customer, you have to think about that metering model of I need to then, each of these individual servers or resources has to understand how to pass information on about how much time was used. So when a request comes in, you may say, well, I processed a gigabyte of data, and it took me 20 minutes and 3,000 CPU cycles, or 3 million, probably more likely. You have to meter that. You have to capture that information along the way. Maybe real time, maybe as a batch process, but that allows you to analyze the consumption of the platform. So you have a more complex challenge in analyzing what's been done, but it's going to give you a higher resource density and resource utilization level. And then there's that third model, which is the containerization approach. Now you've got individual Docker containers. How many folks use Docker today? How many folks know what Docker is? OK, that's good. And then the last question, how many folks can spell Docker? Wow, actually less than use it. That's awesome. It's the beauty of Google. Autocorrect is amazing. In this model, customer one would come in and they would route their traffic to the blue slices, and customer two would come in and they would route their traffic to the orange slices, the Docker containers. The nice thing here is that you can get a fairly reasonable density of utilization of those servers. You get fast deployment because containers spin up faster than virtual machines. And then you can go ahead and track the usage at the container level. So when you add a new customer, you'd go through the Amazon EC2 Container Service, and we've added some nice features in our scheduler, some announcements this morning on that, to then have multiple container models and deployments. You can then talk to that service for deploying the infrastructure, and then talk to that service about consumption as well, in terms of what's being used. You still might consider using some custom metering, but that service can give you at least some visibility into what's being deployed and where you're spending your cycles in that environment. So now there's 3 different models, and actually there's lots of models for how to build this. And the reason why is because you really want to think about how you optimize for cost and performance in the platform. And those are not orthogonal. A lot of folks will say, oh, well, if it's really cost effective, it's not necessarily fast enough. But if it's really performant, it's really expensive. And I don't think that's necessarily true. It's all about mapping the cost and performance expectations of your customer to the architecture you choose. So think about this example. You might have an offering that has multiple different versions. You might have a silver standard offering that is a best effort. It puts messages into a queue to say, hey, I'll process this when I get to it. And there's a fixed pool processing those messages, right? That's perfectly fine. But some customers say, that's not really fast enough for me. Well, you could have another offering that's a gold offering that actually then has a always running high performance computing environment always available. It costs more to run that, so there's actually a higher price point for that offering as well. So you can actually tune your architecture and how you consume AWS resources to the customer need and their expectations around cost and performance. So you want to think about that, and honestly, when you go through an architecture, you want to think about that architecture from multiple different customer expectation sets, right? Here's a new customer. They're a small one. I just picked them up off the internet. They never talked to me. They just signed up for my service. It's a best effort. OK, here's what the architecture would look like to meet their expectations versus this is my enterprise play. These are my highest end customers who are paying a premium to get the best possible version. Here's what their architecture looks like. And you want to think about that not just from an infrastructure perspective, but how your software operates. So you can see in that diagram, there's different queues for processing work, right? There's a best effort queue that goes to a worker pool that is never going to change in size, and then there's a high performance queue, and your software understands how to route that appropriately. The best effort queue might leverage Spot for a much lower price point from a processing perspective, whereas the high performance queue will leverage an always-on fleet of EC2 instances that are doing that workload. So it's really about optimizing around what your customers want and what's going to fit best with that particular business model. And I think there's some optimizations to make architecturally. So ideas of horizontal scalability being the model. I think that everyone gets that one. That's a common cloud tenet. But even the idea of smaller parallelizable resource units to allow greater density. So you, instead of optimizing your code to run in the largest possible box, optimize it to be parallelized in lots of smaller boxes, so you get greater density. So when you add a new machine, you're not worried about consuming the whole box because you can consume more of it with just a small incremental change. And then leveraging the scalable services that you have no work to scale yourself. So something like DynamoDB, where you're not worried about provisioning additional infrastructure, you just pass in an API call to say, I need more throughput, reads and writes. And that simplifies your life in a lot of these scenarios when you're thinking about how to scale and grow from a cost and performance perspective. The other thing to think about is multi-tenancy. I made the example before. Now it's not, when you're building your software, you're not building it for one customer and their user base. You're building it for all your customers and all their users. So it's really a multiple customers with multiple users. So it's a multiplying factor, and it's a significant one when it comes to how you design your software. So an example might be in your data model, where when you wrote your software the first time, you said, well, I got a database, and it's a single customer database, so my schema is such that I just look up all the orders for that customer. Well, turns out when you've got a shared data schema, now you have to have a customer column on top. So now I want to look up the orders, but not all the orders, only the orders for that customer and their user base. So you got to think about how does your data schema change? How do you store and access data differently? So there are some different thinkings when you sort of expand beyond the single customer deployment and go into a multi-customer, multi-user model. I think I talked about this in the last slide a little bit, the idea of providing tiers for request prioritization. Another thing to think about, tiers of performance and response time. And then, of course, I think it's kind of makes sense you monitor everything closely and distribute it efficiently across the platform as best as you can. But that's going to come down to how you evolve and grow your software over time. The other thing that's important to think about, especially when you're running a SaaS, is the life cycle of your data. I've talked to many customers over the years who will say, oh, well, it's great. We built the platform. We got a data model. It's where we're storing it. We're putting everything in the database. And then the question comes, well, how long does it stay in the database? I'm like, well, it stays in the database forever. I mean, so that's the way the software works. You just put it in the database. Well, when you're running it for them, now you got to think about how long do I really want to keep that data? Is that data relevant after 6 months, a year, 3 years, 7 years? And is that really cost effective too? I'll use an Amazon example to highlight this point. When you go to look at your order history on Amazon, the last year or so is going to be kept in a low latency, fast access data store. Because you're going to pull that up, and when you want it right now. It's a pretty common scenario to look at your orders, right? However, if you go back to your orders from 7 years ago, that doesn't need to be in a database. How commonly do you go to that? How fast do you expect that really to perform on your behalf? So in actual fact, that can go to a flat file on S3 to pull that out, right? It's a completely different data storage model because the expectations of performance and the likelihood of it being used are different. So knowing the life cycle of your data and how it evolves over time is a really important one because that actually will have a pretty significant impact in your overall data storage and compute costs. Storing data and paying for a highly performant database for everything doesn't necessarily make sense if you're going to run it all for them in perpetuity. So thinking about that from a design perspective is an important one. And then the last one, and I'll harp on that. I could harp on this all day long. This could be a whole talk by itself, is really collect everything and learn from it. The most important thing to realize is you can't improve something if you can't measure it. Right? If you don't have data that you're looking at, you don't know if your change made an impact. Right? So you really do have to collect across the board. So obviously, closely monitoring infrastructure makes obvious sense. You want to make sure everything's running smoothly. You want to collect your metrics reliably, and you want to store them durably. The idea here is, hey, rotate your logs, drop them at S3, keep them forever, because who knows when you want to go back and analyze the last 5 years of usage and understand what your customers were doing back then versus now, and how that's evolved over time. If you don't have them, you can't look at them. And there's obviously lots of storage models that can make this cost effective. Know your customers. So one thing that this is a story that's interesting is we had a customer who was building a SaaS offering, and they had been storing a whole bunch of data and building search on top of it. Well, one of the challenges came later on when search got really expensive to run. It was very complex to build the indexing servers, and there was lots of data storage. It was a whole nother data set, really. They discovered they didn't have the information in their application to analyze who was calling search and what they were searching. They didn't really have the data about the customers and what their activity was. So the idea of instrumenting your code all the way through, so not just the calls to the front end, but the calls to the app tier and the database and the other ancillary services all contain a customer identifier we're not talking a social security number. We're talking an obfuscated identifier you can use to identify unique users. Allows you to know who they are and what they're doing. It allows you to analyze what's happening. And that's not necessarily a common design principle in a lot of software. But analyzing that who's doing it through the entire platform gives you the ability to know your customers and what they're really doing, and then evolve based on that. And that's actually probably the most interesting part about how SaaS changes the traditional software development model, is that now you actually have real data about what customers did, how they used it, when they used it, what they did with it, how long it took them, how often they use it, things that you may never have had before. When you think about shipping bits, you never necessarily had the visibility into what they're doing. And we're not talking about, NSA spying. We're talking about basic, monitoring of your platform and how it's consumed. That's really what you can do now and have a visibility into it. And it allows you to evolve based on it. You can change your software. You can create differentiated offerings based on consumption models. You can really monetize the data you collect in the sense that you can evolve the platform and make it more efficient because it's you know the common scenarios. You know what customers are really trying to do. I think those are some of the big best practices we've collected from our customers over the years, and I think this one is the one that I obsess most about when I talk to customers. So with that, I'm going to call Brian back up to close it out and get you closer to some beer.
All right, are we on time? What time is it?
Yeah, we're always on time.
All right.
We got the stage, we're on time.
Okay, well, yeah, well, thank you again for joining us today. A couple of things, depending on who you are in the audience. If you're a software company and you're interested in joining the APN, the AWS Partner Network, and you haven't done so already, please go do that. Once you join the APN, you'll be able to register for the SaaS Partner Program. Right? That will kick off a workflow. Your application will come to myself and Osley down here, who's running the program for us, and we'll get you access. Once you get access, we have some recorded content on there. So a lot of the stuff that you learned here today are going to be webcasts that you can actually just watch. So if you didn't have to write down furious notes and learn, how do you spell Docker?
D-O-C-K-E-R.
Okay. If you need to learn how to spell Docker, we have these recorded webcasts there that you can go view. And also, again, starting May 1st, we'll start to have office hours. So please sign up for those. Actually, I think you and I are probably the ones who are going to be moderating office hours.
You'll be talking to us again, basically.
Yeah. So I don't know, is that a pro or a con?
I'm going to put that in the net neutral.
Okay, how about you cover the business topics and I'll cover the technical topics?
It's like backwards day.
Yeah, it'd be backwards day. And then, as the portal evolves, continue to ask questions. Again, collaborate with those in the community. And then the last point is just stay tuned. This is going to be a rolling launch. We will continue to provide additional features, additional benefits to our SaaS partners. We're going to evolve the functionality in the portal to make it easier for you to collaborate. There's a bunch of things that we're going to do over the course of this year and next to make this program a lot richer and make it easier for partners and customers of all shapes and sizes to come and build very successful SaaS businesses on AWS. So with that, we'll conclude. Matt and I will stay around up here someplace and happy to answer any questions. If not, I believe there is a reception going on right now over in the exhibit hall. So thank you so much for your time. Really appreciate it.
Thank you.
Have a good evening.